guys, Mike. Welcome back to the shop. I know it's been a while since I posted a project video. I've been working on the milling machine, trying to get it up and running. I've got it all back together except for the drive pulley, which is sitting over here on my welding bench because I need to make some measurements, and I'm going to have to bore this out and sleeve it so that it'll actually hold the bearings that attach to the spindle for the milling machine. Got it all hooked up, was all excited until I fired it up, and it was rattling like crazy. And I looked at it, took it apart, figured out what was going on, and this lower bearing seat here, the bearing just falls in and out. The top one, there's a little bit more tension, but you can get it to drop out just a light tap on your hand, and it'll knock it out. So I'm gonna measure. I'm gonna make a sleeve up to fit this. Now, I don't have a whole lot of room to work with here. Let me flip the camera around so you guys can see what I'm talking about here. So, inside here, there are two internal snap rings. And this hole is 1.87 something. I don't have my micrometer over here right now, or my caliper, but I'm going to have to cut these internal grooves for the two snap rings here. So I have my depth mics over here to take that measurement from that one, and what I'm going to do is I'm going to take this measurement, pull this one out, measure the bottom one, and then pull it out, and both measurements are going to be from this face here. I'm going to chuck it on my forejaw so I can get it spinning true. I'm going to expand it out to hold it, and then when I go to do this cutting, I only got a little over an eighth, maybe 3/16 of an inch in between these two holes, and this is where the drive plate bolts down that actually rotates the turret or the spindle in the mill. So I don't want to cut into those too much. So what I think I'm going to do is pull these out, and then I'm going to bore it to 2 inches. I've got some 2-inch bar stock I can turn down, bore out, press it in with some retaining compound, and then cut the grooves, and hopefully be able to do it like that. Get it back up on the lathe, dial in off of these faces here, this one and probably this one here. These are probably the two best machine surfaces, here and here. That way I can get it bored to size to fit the bearings so that I can get my mill back up and running. So that's the project for today. I'm going to get my depth mics set up. I'm going to get my telescope gauges set up, and then I'll bring the camera back. Alright, got everything set up here to do the measuring, which I did off camera because I forgot to hit record. Our two measurements, the first ring, we're at 0.667 from this top surface. Second was 0.845. Measure these to see how thick they are, but they're 1/16 of an inch thick. So the next thing we need to do is measure the bore that's here. As you can see, this is what the reason why we're doing this is not a very good fit for a bearing. These are supposed to press in, and it's got way too much slack. But even the top side, which isn't nearly as bad, it's still got too much play for me. So let's measure out. Let's see. So this side is a half thou over the bearing, which is 1.85. So we're at 1.8505. Yeah. Alright, let's see if I can check this bottom side to see what the difference is on it. It's 2000s big. Yep. So the taper, this thing is basically tapered now, going up like that. From, I'm assuming just from the forces pushing against it. It's pivoting more on the bottom than the top. And this machine has been run quite extensively. Based on the bearings and everything else inside when I was rebuilding it, it looked like it'd seen quite a bit of use. Now, I've got these pins here, which are about 2 1/16 apart, and then these holes, I'm just going to go right to the edge of what's there. That's 2.158, and the threads go in just a little bit further. So I've got more room or less room in between the pins, so that's what I'm going to do my cuts based off of, and it's 2.65. I think what I'm going to do is just bore this out to 2 inches. First I'm going to cut a piece that's going to go in here, then I'll cut this to match, and then what I'll do is I'll put sleeve it and then cut it to size after I put the sleeve in. So I want to do the sleeve first. I'll just leave the ID, which will be the bearing fit. I'll leave it small until I get everything pressed in, and once I get it all pressed together, then I'll do all the rest of the machine work. That way everything's turning concentric to the actual belt pulley groove. So I still would really like to pull these pins out. I've tried a couple different things, nothing's worked so far. I might try heating them up and letting them cool down, see if they're Loctited in. Hopefully that'll break it up if it is, and we can get those out of the way. I mean, I could leave those in, but I don't like leaving two swinging things like that out when I'm going to be turning something on a lathe. Too much risk of it grabbing and ripping something. Alright, so I've got you set up over on the lathe. Should I kill them that light? Put the light back on, just not aimed that directly on it. That looks like it's good on my view screen, but we'll see how it turns out. I found this piece, which is a 2-inch OD. Inside is, I think, 1 7/16 or something like that is what I bored it to. And I just put 4 screws in, and I used this as my fore jaw before I got the fore jaw for the smithy. So I would just chuck it up in here and then use the Allen set screws as, or the socket cap screws as my fore jaws. And it works fairly well for that, but now that I have a fore jaw, I don't really need this part all that much. So I measured, and the bore of that pulley is 1 7/16 deep. So this piece is, or sorry, 1 inch and 5/8, I think. I might be mixing up my measurements, but this piece is long enough, either way you look at it. So what I'm going to do is I'm going to bore this, and I'm going to leave it about 20 thousandths proud of where it needs to be, so that once I get the pulley mounted up and bore it out, I can press this in and then finish the cuts on the inside of this so it's truly matched to the pulley. I still have to get a tool ground up to do the groove for the snap ring. I don't have one handy that's got a full grind on it right now, but I think I got something sitting around that'll probably work. So we're just gonna fire this up and go through, cut this just to do a cleanup cut to see where we're at. I'll set my feeds and speeds kind of slow here, make sure I'm in the right direction. Actually, before I do anything, make sure I have adequate clearance here. Alright, so I've got one of these Brazone carbide boring bars, and this actually works really good with this setup. I can get in there and cut and it doesn't ring too much normally, knock on wood. Okay, and this boring bar is cutting like garbage in this one. I'm gonna change my angle here a little bit and see if that helps. Make sure I still have adequate clearance. That left a much nicer finish in there. I think it'll work. The only thing I want to do is I want to cut it, at least cut these holes off here so they're not in the way of anything. And actually, before I do that, I'm going to do a quick facing cut here just to make sure everything's true. And really the only reason I did that was that it lets me bring this in to true up the cutter. Alright, let's see. This might be an interrupted cut, which means I'll have to go really, really slow. So I wanted to leave it a little long. And that'll give me good 20-30 thousandths there. Lock everything down. I'm sure I'm gonna have to go ridiculously slow. Just camera angle a little bit here and see how this goes. I've never really used this cutter for an interrupted cut before. It's smoking, but it looks like it's cutting nicely. That went surprisingly well. You can see cut right through that thread section without a problem, and it actually isn't even really that hot, which is surprising. Face this off again. Let's get a nice clean surface here. Looks good. I'm just going to kiss that front edge there. Chamfer the outside diameter. On the inside, but that's alright because we're going to cut all that off here in a second anyways. Okay, now that I've got that back with no interrupted cuts, get my boring bar set up here again, and we'll make another pass with it. from this bit. It's just not cutting how it normally does. So I'm going to get out my heavier boring bar here. Let's see how it does. Looks like it's going to go all the way through without a problem. This is a much nicer bar, except for the fact that it needs a quick hone. That feels like it's got a much better edge going on now. Oh yeah, that's 1,000 times better. And it's, I think I need to actually take this over and just touch it up on the grinder. So I'm gonna go touch up this bar, even with that's still got a little bit of burr there. I'm gonna clean that up and then we'll get the rest of this done. Alright, so I got the tool bit resharpened real quick up on the grinder. Have everything set to make a good finishing pass through here, just to see how it cuts. Before I do that, get some lube in here and make a finishing pass and measure. That way my DRO is calibrated to a finishing pass depth of cut. I learned on one of the last projects that part of the reason why my DRO is always off is because I measure a different thicknesses of cut, and it's taking off a different amount of material. So I'm doing it this way from now on. Hopefully it works out for the better. Well, it still has some surface imperfections. It's not really smooth. And I'm thinking I need to grind a better radius on this tool. Right now it's got a fairly sharp corner on it, and it's just not the surface finish that I want, especially considering once I mount the pulley and everything up, this is going to be the bearing surface. So I'd like to get a little bit better of a cut going on it. So I'm going to take it back over to the grinder again, try to get a little bit of a better radius on there.